So before I have two performance data, wanted to share some of the work we've done around ensuring our products are ultimately sustainable. And so what we've done at BT is our goal is to provide a high-level life cycle assessment to our customers for all the combinations of feedstocks and manufacturing configurations that we use to produce our products. Just out of transparency, is we are an asset-light company. We mainly partner with tollers to produce our products throughout the world. We have tolling contracts on multiple continents to do that. And what we're trying to do is then create life cycle assessments with our partners all the way from kind of the start of the growing of the oleic-derived or the oleo-derived chemistry we're using to the final product getting ready to leave the gate of our manufacturing facilities. You know, a good example of this is if we would do a study on, say, high oleic soy oil derived fatty acids that are used in production of BT4 that might be produced in a plant here in the United States that's ultimately used for our passenger car motor oil products. Or in other cases, we have castor-derived fatty acids they use in making the BT22 and 75. Those are produced in India, and we might be using them for hydraulic fluids. So that's the idea that we try to provide to our customers. In general, we want to use the ISO 14040 methodology, but we probably keep it a little higher level than it's called for in that ISO. And in general, we're thinking kind of 10 key areas when we do our life cycle assessment. Things around like global warming potential, how much CO2 is emitted, methane, et cetera. Acidification potential, really around SOx and NOx emissions. The types of fuels being used to actually produce the materials. Now, this will impact, obviously, the CO2. There's other impacts as well. So we're looking at fossil fuel depletion. Habitat alteration. I think this is a very important issue, especially when you're dealing with oleochemistry. Are you competing with things that, like, say, land that's being used for other purposes? Are you deforesting? What's the impact as you grow? Air pollutants, especially particulate emission when you're working. Human health. We look a lot around the socioeconomic impact of our product and how it's manufactured. Are there GMO implications? Smog, ecological toxicity, so aquatic and soil toxicity, heavy metal contamination, water utilization in growing these crops, and the overall kind of air quality, especially around agricultural impact and production processes. And so we've done that, and the one I want to share today quickly is the castor derivative LCAs. So we partnered with Gujarat Agricultural University to look at all the way from the start of the seed planting for castor products through the collection of those materials, delivery to the processing facilities, and eventually turning that into an intermediate and a final product for BT. And so we partnered with, let's say, that the Agricultural University, our Indian toller manufacturer and their research and development department, and then our team here to kind of map that out. We drew out essentially all the high-level inputs and outputs for these systems, and I won't go this into detail, but it looks at things like how many seeds you use per acre, how much nitrogen, phosphorus, sulfur is required, are you using pesticides, herbicides, what's the general yield of the castor plot, how close are they planted together, how much water is needed from irrigation, how are they harvested, how are they transported, and we went through that in this study. And what we found is from a number standpoint, when you put all that together and you look at every step of this process, the seed farming all the way to the final product, is the big impact is the land that you're using to grow to castor is essentially dedicated to castor. And it's not like we're clearing a rainforest or other trees, and it's really kind of, semi-arid region that's kind of scrubland that's being turned into agricultural. So in a lot of ways, it's a big carbon sink for CO2. So in that impact, there's a really large negative carbon uptake from that product. And then the biggest component of that carbon is that they take the waste of the seed crushing process, so the spent mill from that castor, and it's actually what's used to drive the boilers that produce the steam for the oil refining, for the initial, ricinoleic or the fat splitting, and then the ricinoleic production, and the 12-hydroxysteric, and finally our process. And so most of the carbon offset is coming from burning that CO2 that was captured, and then offsetting that from the steam produced. Now, what's nice about that, though, is we're not using any natural gas or coal or fuel oil to drive those boilers. It's just that caster mill, and so the carbon offset is minimized greatly. So from a high-level standpoint, what that really means is our product leaves our customer's facility with a net negative 9-ton carbon CO2 balance. And that allows us to actually transport our materials across oceans and still arrive in a negative carbon footprint when it arrives to our customers. Now, the end use of the product will ultimately dictate the full life cycle assessment. Since we don't know that for all of our customers, we can't quite calculate that. But what we do to our customers is we give them the state from all the components you see as it's at our gate, ready to be delivered to them. And then if there's a desire to move the life cycle assessment further, we can do that. So if you summarize all that up, though, of like all that impact we talked about, this is kind of what our LCA from a high level looks like. Is we actually went, we visited the fields, we visited with the Caster Consortium in India, we visited the plants, we did the audit, and we really do like the overall sustainability story with Caster. One is Caster doesn't compete with food crops. It's really land that's not being used for anything else, and allows some of the poorest farmers to come out of poverty. Crops can be harvested multiple times. It's done by humans, so there's low CO2 balance. There's no GMO implications. It's all naturally derived Caster. You're not competing with food. And then the way it's manufacturing at our manufacturing facility by using wind turbines, boilers that use in Caster spent cake, and the high level of integration in that province region of India allows us to be a very sustainable and carbon negative manufactured product.